Welcome back. Lesson 6 in our Unit 3 of our AP Calculus course. Today's lesson is about applying the chain rule. In the previous lesson, we introduced the chain rule. Now we're just going to practice applying in a few different situations. So let's get right to it. I want to start with some practice problems for you to just kind of get going, and then we'll pause the video and we'll check them. You can try and do all of them. I think there's like 5 of them, or you can do them one at a time and just pause the video in between. All right, so let's check them. I'm going to rewrite this as 2x squared plus 7x to the 1/3 power. So this is f prime of x is equal to 1/3 times 2x squared plus 7x to the negative 2/3. Remember to leave the inside alone and then multiply by the derivative of the inside. Be sure to put parentheses around that chain or else it won't be right because you got to have this times the entire 4x plus 7. All right, let's do h of x equals sine to the 4th of 3x. So that needs to be rewritten as sine of 3x all inside a 4th power. So h prime of x is equal to 4 times the sine. If you don't mind, I'll go ahead and put the exponent back here now. It goes down to a 3. Now I have to multiply by the derivative of the inside, which is cosine of u, which is 3x, times u prime, which is 3. All right. Let's do the next one now. So dy dx. This is tangent cubed, so I'm not going to rewrite it, but hopefully you agree that it's 3 tangent squared and then 7x plus 1. Now we multiply it by the derivative of the inside. The inside was tangent u, which is secant squared u prime. All right, let's do the next one. Oops, looks like we got to use our product rule here. Y prime is equal to derivative of the first. The derivative of secant is secant u tangent u prime. That's the derivative of the first times the second, which is the sine of x squared plus 1, plus, you mind if I bring it down here, plus the secant of 2x, the first, times derivative of the second, which is cosine x squared plus 1 times derivative of the inside of cosine, which is 2x. Whew, that was a long one, right? All right, let's do the next one. All right, let's rewrite this as x over x squared minus 1 to the 1/5. So f prime of x is equal to low d high, which is 1, minus high d low. Leave the inside alone. Then multiply by the derivative of the inside. All over low, low. Which makes it to the 2/5. All right. Okay, let's go on to example 6.1. Find the equation of the line tangent to the line y equals 2x to the 4th plus 6 to the 2/3 at x equals 1. So to find that tangent line, let's do, let's find the derivative, because the derivative will tell me the slope of the tangent line. So y prime is equal to 2/3 times 2x to the 4th plus 6. Subtract 1 and I get negative 1/3. Then multiply by the derivative of the inside, which is 8x cubed. Now to write the equation of the tangent line, I'm going to need to know the point of tangency. So I have the x value that we're supposed to use. Let's get the y value using the original function. So I'll simply plug in 1 for x. 1 to the 4th is, of course, just 1. Oops. There we go. So this is y equals 8 to the 2/3. Now, when you evaluate a fractional exponent, and in AP Calculus, you need to be able to do this, especially for the multiple choice portion. You take the root of with the bottom and you power from the top. So I always say that a fractional exponent is just like a tree, right? It has its roots down below, but it gets its power from the sun up above. So power up above, root down below, and always do the root first. I don't want to take the cube root of 64. Let's take the cube root of 8. That's 2. And what's 2 squared? 4. So it's y equals 4. So we now know the point. Next, we need the slope of the tangent line. We got the point of tangency is 1, 4. We need the slope of the tangent. So we'll do y prime of 1. That's 2/3 times 2 times 1 to the 4th, which is just 2 times 1 is 2. All right, times 8 times 1 to the 3rd is just 8. Okay, so this is 2/3 times the cube root of, or times 8 to the negative 1/3 times 8. So what that's going to do is that's going to move this 8 down to the denominator where the 3 is. So I've got a 2 times 8 on top because the 2 is on top and the 3 is on bottom with an 8 to the 1/3. So when I move it down, the 8 to the 1/3 became positive. So this becomes 16. The cube root of 8 is 2, and 2 times 3 is 6. And we could go ahead and reduce this since we're doing all this work. 8/3. So the equation for my tangent line is in point slope form. Y minus the y coordinate, which was 4, equals the slope times x minus the x coordinate. There we go. All right, so let's do another one. The derivative of the derivative of f is called the second derivative. Oh, we're finally introducing the second derivative. Good. So the second derivative is really important, and we will learn a lot about it in our next unit when we get into next couple of units when we get into real problem solving and applying the derivatives in general. But for now, I just want to practice taking the second derivative. So what we do is we simply take the derivative, and then we take the derivative of that. Okay. So we have f of x is equal to this stuff. So let's find out what f prime of x is. Okay, so I need to bring down the 3, and it'll multiply with the 2, giving me 6. And then the inside stays exactly the same, and that goes down to 2. Then we multiply by the derivative of the inside, which is 4. Now, normally I don't do a lot of simplifying, but if I'm going to find the second derivative, it sometimes is easier if you do a little simplifying. 6 times 4 is 24. So yeah, I think that one's going to help a little bit. Maybe not always, but this time it helped. Now let's find the second derivative, which we write 2 primes. Okay, in case you're wondering, f to the third derivative is that. And then the fourth derivative, they switch into Roman numerals or something. But you don't usually see a fourth derivative too often. It's not really that applicable. I know it's used in some things, but I don't ever use it. So the second derivative is 48, and then we get 4x minus 1 to the first, and then the derivative of the inside is a 4. All right, so that's the second derivative. Okay, we got one of our favorites here. We got one of our picture problems. That are oh so prevalent on AP test problems like this. So not this problem. I made this one up myself. I didn't want to steal from the AP exam, but I certainly got the idea. So let's work these problems. So pause the video and do it. All right, let's see how you did. So h of x is g of x times f of x. So then h prime of x would be g prime of x times f of x plus g of x times f prime of x. So it's g prime of 6 times f of 6 plus g of 6 times f prime of 6. Now f is green, g is red. Oh, I should have g be green. That would have been easier, right? Green for g for green. So g prime at 6. Well, I go over here at 6, and I can see that the g prime, which is the slope of g at that point, is a negative 2. F of 6 which is the green line, is 4. G of 6 is 2. But f prime of 6, which is the slope of f, is a negative 1/2. And you can go ahead and figure that out if you want to. It's what is that, a negative 11, negative 9, looks like. But I'm not going to simplify it unless I absolutely have to, so I won't. But we can't leave function notation in our answer. All right, k of x equals f of x over g of x. So k prime of x equals low d high. So low d high minus high d low all over low low. And because I don't have a ton of room, I'm going to go ahead and try and plug in the 1 and evaluate at the same time, something you should never do on a test. But k prime of 1, so I'm going to put a 1 in. G of 1 is 3. F prime of 1 is 2, because the slope of the green graphs is 2 there. F of 1 is also 3. G prime of 1 is a negative 1 over g of x squared. G of x squared would be, our g of 1 squared. G of 1 is 3, so squared would be 9. All right. Okay, now we have a product rule problem. So the m prime of x is derivative of the outside, so g prime, but the inside stays exactly the same, times f prime, the derivative of the inside. Now let's find m prime of 5. Well, that's g prime of f of 5 times f prime of 5. So what is f of 5? Well, f of 5 is, looks like 4.5. So this is g prime of, I'm going to give myself a little bit of room because I can do that with this. So, because this is important. So I'm just going to move this over here. I can pull it back later if I need it. So there you go, over there. But I don't want to try and squish this in too much. So f of 5, we said was about 4.5, right? And it won't matter because we'll just need to find the derivative there. So we'll be finding the slope there. Times f prime of 5. Well, f prime of 5 is negative 1/2. Because the slope here is down 1 over 2. So now we find g prime of 4.5. So we need to move over a little bit here, right? So actually just a little to the left of the 5. So we move over a little bit, and g prime of that would be, what's the slope of that line? Up 2 over 3. So it's 2/3 times the negative 1/2, or a negative 1/3 if you want to finish it off. So that's pretty exciting, I guess. All right. Next up, letter D. We have r of x is equal to g of 3x. Okay, so r prime of x is equal to g prime of 3x times 3, because of the chain rule. Derivative of 3x is 3. So let's find r prime of 2. Well, that's equal to g prime of 3 times 2 is 6 times 3. Well, g prime of 6 is a negative 2. So the answer is negative 6. All right, let's do letter E. What is this? All right, so q prime of x is equal to g prime, keep the inside the same, times the derivative of the inside, which would be cosine of x. So then q prime of pi would be g prime of 1 plus the sine of pi times the cosine of pi. Now, cosine of pi is negative 1. The sine of pi is 0, so this is g prime of 1 times negative 1. Well, what's g prime of 1? G prime of 1 is negative 1. So it's negative 1 times negative 1, which is 1. Oh, that's a lot of work just for that one. All right, let's do f now. And is that our last one? I think it is. Oh my goodness. Yeah, it is. It's our last problem of this lesson too. So here we go. Oh, quotient rule. T prime of x is equal to low d high minus high d low all over low low. T prime of 3. T prime of 3. 1, 2, 3. So, all right. I got to do f of 3. What is f of 3? 1, 2, 3. F of 3 is 0. No. No, it's not. What am I talking about? The slope of f of 3 is 5. So that's 5. G prime of 3. So that's the red line. At 3, G prime is up 2 over 3. So 2/3. Minus G of 3, which is something awful. We're not going to calculate that super. They don't do that to us normally. But I'm betting it doesn't matter, so I'm just going to call it 2 and 2/3. So that'd be what? 8/3. But it doesn't matter because guess what we're multiplying it by? We're multiplying it by f prime of 3. See that? F prime of 3. Well, f prime of 3 is 0. So that's going to go away. All over f of 3, what did we say f of 3 was? 5 squared is 25. So this is whatever this monstrosity is. 5 times 2/3 all over 25. If you're wondering how to do that, that over 3 can come down here. That can reduce. So it's 2/15. All right, well, that's it. I look forward to the next lesson. We're going to get into some inverse functions, and that opens up our whole playbook for derivatives coming up. So we're coming in on the home stretch of this pretty long unit as we go over all the different derivative rules. But get it under your belt and start memorizing them. All right, till I see you again. Take care.